something. Right. So yeah, so after having to have proven what we have proven, right? The next question is important, because the next question is asking us the following, right? It says there, what does it say there? It says prove the identity. Okay, we proved the identity. Then now they said for 2 marks, for which values of x in the interval 0 to 360 will the identity in question 5.3.1 be undefined? So in terms of something being undefined, you know, you have like a few pointers to look out for. The first thing is you want to look out for things like, you know, surds. The next thing you want to look out for is, I'll put this here. I'll put this and I'll write it in words. Here you want to look out for 0 as the denominator. When I say 0 as the denominator, you want to look for things that will cause the denominator to be a 0.
Yeah.
And we'll show an example just why. And then secondly, you know, 10. You want to look out for 10, because if you're looking out for 10, you want to think of asymptotes.
Okay.
You see, because if you can look for asymptotes, then you are good to the go. You are good to go. So with what we have here, I mean, if you can think maybe of another one, I mean, if we think a bit more, yeah, I think these are the ones to look out for the most, you know, because when I mentioned surds here, you want to look for things like, you want to look for specifically what's under the surd. So when I say surds here, you want to look for where what's under the surd is a negative. So if you had, let's say, something that is a square root, right? And then they ask you, where is this expression, like, you know, undefined? This expression will be like undefined where the cos x minus 1 is smaller than 0. You see, so you would need to work this out, because as long as you work this out, you would be working out where the expression is undefined, because the surds tell us that the expression will be undefined if the bottom part here is a negative. You see, with fractions, the denominator, with fractions, we have to check where the denominators are as 0, because where the denominators are as 0, we will have something that's undefined. And then if you have 10 somewhere, let's say 10 theta, you know, if you have 10 somewhere, you have to think of asymptotes, you see, because with a 10, you know that your original 10 graph, let's say here, original 10 graph has asymptotes where x is equal to 90 to 70, going on and on and on. You see, that's what we know based on our knowledge. So you want to think of things like that. So while we're talking now, you have to remember that your what you may call your asymptotes always split up 10 graphs. For example, if we draw something very long here and also a bit to the left, original 10 graphs, they will be spaced out after every 180 degrees, you see. After every 180 degrees, you'll see a complete 10 graph. That's why you'll see something like this. This is half a 10 graph, and then something like this on the other side, it's a full graph. This is half a 10 graph, full graph.
Yeah.
This is half a 10 graph and then full graph. And then here, obviously, you have what you may call half a 10 graph. So with something like this, automatically you want to remember that this is like a 90 and a 270, you see. In this space, this is 180 degrees. So for future reference, right? If you see stuff like, let's say 10 with like 2 theta, right? Then this should give you the indicator that you have 2 10 graphs in a space of 180 degrees, you see. So here the reason I'm mentioning this is that your asymptotes will be e.g. 90 divided by 2, 270 divided by 2, going on and on and on. You see, so your new asymptote will be like at 45 and at like 135, going on and on and on. You see, if your graph was not like moved to the left or to the right or anything like that. So meaning something like this, right? If you're going to draw it in a Cartesian plane, in a space of 45 degrees, you'll have half a graph. So you'll see something like this. And then in a space of 90, you'll see like a full graph. And then obviously here you'll have another asymptote, you see. And then obviously it just carries on like that, you know, where your asymptote here is gonna be 45, and then this is like 135. So that's for if you have a 10 symbol in your expression. That's what you work out. It's gonna be undefined where you will have like asymptotes. So in our case, we have this one here. We have fractions only. So because we have fractions only, we have to work out where our denominators are zeros. So we have 2 distinct denominators, this one and then this one. This one is just the same as that. So we don't have to like, you know, do any third thing. So to check where this is undefined, we're going to check where, for example, where 1 plus sine x is smaller than 0. That's what we work out first. No, is equal to 0, sorry. Equal to 0. So this is equal to 0 if, let's say, we have to solve for x. So solving for x, we have to be careful, because here this is going to give us a reference angle only. Remember, when you solve for x and you're dealing with trigonometry, anytime you're about to do shift, sine, anything, always get a reference angle, not immediately an answer.
Yeah.
It will save your life. And then this symbol here, only just use it to work together with the reference angle. So our reference angle here, you're always going to get it from taking this individual value without considering the number in front of it. So in our calculator, shift sine is giving us shift sine 1, right? This is going to give us a 90. And then the reference angle here is 90 degrees, right? So now we can make use of our cast diagram and use this sign here. That sign in front here is telling us we should work in the negative quadrants. So it's going to be here and here. So it's 180 plus and then 360 minus. And then let's see here. So with all this being done, right, we know that now in the third quadrant, let's see what we can do here. In the third quadrant, we have 180 plus the reference angle. And then here, this is, no. X is got 180 plus the reference angle. And then this is plus K360. K is the element of integers. This is going to be, let's see, 270. X is 270 degrees.
Yeah.
You can add the plus K360 just for the vibes, you know,
Mm.
because this is just, you know, something extra. But then the next answer here, it's 360 minus, right? So minus the reference angle plus K. Oh, no, we're dealing with sine. Oh, yeah, I thought we're dealing with 10. I was about to panic. Already. So K360 here. K is an element of integers, right? Then this is like 270 again. Oh, well, so we already have 270, so it's fine. x is the expression. This is the first answer, right? It's gonna be undefined where x is 270. The other side, the other part where it's undefined is where cos x is a 0. You see, because that's also something in the denominator. So let's see here, cos x equal to 0, and then cos shift cos is 0. I mean, you know, with 0, I mean like 0 is 0. But again, we said let it just be a habit that anytime you get a reference, anytime you do shift sign anything, always get a reference angle. You see, because from here, shift cos to 0, we're gonna get a 90. Oh, okay, this is interesting. Now, when you're working with a 0, the funny dumb thing is that you basically just work with the parts where this thing is a positive. I know it's weird. So this is our reference angle, right? So we're gonna work in the first quadrant. In the first quadrant, you just take this as your answer. And then in the fourth quadrant, we know it is 360 minus, we already have that 360 minus our reference angle, which is 270. This we already have, right? So this one is just, you can add the K360K as element of integers, but the fortunate thing is, if it's not like the general solution that they're asking for, you don't have to put this, but if you put it, you're not like gonna be penalized or anything. Because here within your, for the question given, oh yeah, but the only thing is because here it's between 0 and 360. Yeah, it's okay. It's okay. We can just leave out the K as an element of integers part. Because this almost implies that we have like all those other answers that are going to be above 360 or below below 0. So this one we can leave it out.
Yeah.
Because it's
And
just, we're
then
just
it
showing
would,
for x.
and then it would be x equals 90 or x equals 270.
Yeah. So here I can say therefore x is 90 or x is equal to 270. That's where this will be undefined, because if we put 270 inside our expression, let's say we put 1 plus sine 270, 1 plus sine 270, it's giving us a 0. So that would cause us to get something undefined. And then here, if we had cos 270, it's also going to give us a 0. So it means our expression would be undefined. So yeah.
Yeah.
That's for 5.3.2.